So a nuclear energy can be released by energy which is released by a nuclear reaction is called a nuclear energy. An energy which can be released by a chemical reaction is known as chemical energy. So what happened on the surface of the sun? The sun consists of hydrogen and helium atoms. There are millions or trillions of hydrogen and helium atoms. So when these hydrogen atoms combine with each other, join with each other, they will form a helium atom, a heavy atom. So what we call this nuclear reaction, when lighter join to form heavy, fission or fusion. The lighter hydrogen atom join to form a heavy one. So when the lighter atoms join to form a heavy, this is called nuclear fusion. Fission is opposite. In fission, what happens? The heavy break down into lighter. So example, if I have uranium, which is 92, and I target this uranium by a neutron, because neutrons are easy to move through the nucleus, and it break down into smaller atoms. So when the heavy one break down to smaller, we call that as a fission reaction. And this fission reaction we carry out on this in different power stations. Maybe you have heard of nuclear power station. Some power stations generate electricity by a nuclear reaction. So they carry out a nuclear fission reaction which releases energy. So in a nuclear fusion reaction, combining the two lighter nuclei to form a heavy, which release energy. So as you can see, we mix hydrogen isotopes, two isotopes of hydrogen, and this result in a formation of helium and one neutron. It can be neutron, it not necessary, but it produces a heavy nucleus, so that's we called as a nuclear fusion reaction. And on the sun, this happened that a nuclear fusion reaction occurred. And in a fission, what happened? The heavy nucleus split. As you can see here in this figure, you have a uranium nucleus. This is only the nucleus, not atom. That's the nucleus of uranium. We target by a neutron that knock out other particles and make into lighter one. So when the heavy nucleus break into lighter, we call that as a nuclear fission reaction. So nuclear energy can be released by two ways. One is nuclear fission, another one is nuclear fusion. Then the concept of the wind energy. Wind energy and wave energy, you can include both of them, or tidal energy. Now how wind energy is there or it is produced? Like this is our sun. And sun is providing heat and light to us. And major portion of the earth is water. So majority or vast portion of the earth is water. And the remaining portion is land. Now what happened? The sun is providing heat and light, so it is heating the water as well, and it is heating the land as well. But because the capacity of the land to store heat energy, because its size is smaller, so land can store less energy. And water, because having a greater capacity to store energy, so water can store more energy. So if the land cannot store too much energy, so what happened? The black spots are representing the air particles. So these are the air particles in our atmosphere. So because the land is not able to store too much energy from the sun, so the land start to release that energy because it cannot store too much energy, having a smaller amount as well as lower capacity or capability. So as the land become warm quickly, or land become hot quickly, it will start to release the energy to the surrounding. So when the land start to release that energy to the surrounding, what happened, the air particles above the land, it become warm, and when these air particles become warm, they will rise, they will move up. So when these air particles which are above the land, they move, so the relatively colder air, which is above the water will start to move towards the land, and this movement of the air particle towards the land, it produce wind energy. Is it clear? The origin of the wind energy. So what is the source of the wind energy? The source of the wind energy is the sun. So what happened? The sun is providing heat energy to both land and water. The land become warm quickly because the amount or size is smaller, so it does not have capability to store too much energy. So as the land is not having capability to store too much energy, start to give out energy. When the land give out energy, the air above the land become warm, and when the air become warm, it rises. So why the cold air is moving towards? Because what happened? Air particles are moving randomly. It's like a diffusion. Because what happened? That when the air above the land become warm, so there are less particles of air above the land as compared to that above the water. So they diffuses from a region of higher concentration to region of lower concentration, and this movement of the air particles is known as the wind energy. And when this air is moving above the water, it produces waves as well. So we also call that as wave energy. Why the land is having less air? Because what happened, when the land become warm, the land supply that energy to the air particles. When it supply energy to the air particle, air become warm here. When the air become warm, its volume increases, because when something become warm, the particle move away from each other. As the particle move away from each other, its volume increase. So as the volume increase, its density will decrease. So as the density of the warm air decreases, that's why it is rising. Is it clear, the concept of wind energy? Any question? You can use a chat, or you can use a mic if you have any question or a doubt. Yes, Heather, Shahzeb. So basically the source of the wind energy is the sun. So if we don't have sun, we cannot have wind energy or wave energy. So when maybe you have observed this, if you are standing at a seashore, you will find that the movement of the air is much observable. You can observe the air current or air movement easily. So when the wind energy is caused, sun is the source of many forms of energy. Sun is producing energy due to nuclear reaction. Basically what happened, like this is our sun, which is having hydrogen and helium. These hydrogen atoms, so which form of energy the nucleus will have? They will have nuclear energy. When they combine with each other, they produce helium due to nuclear fusion, and that release energy and that release heat and light energy. So when it releases heat and light energy that we receive on our planet, so when we receive that heat and light energy on our planet, because the land cannot absorb too much energy due to its smaller amount or capability, so the air which is above the land will become warm, and air above the land, as it become warm, it will rise. So here less particles of air, so the air which is above the sea start to move or diffuse towards the land. So the cold air will move towards the land, and this movement of the air we call that as a wind energy. And when it is the air, wind is moving over the surface of the water, it also produces waves. So it will have wave energy as well. So sun is that's why we say sun is the main source of energy. Sun is producing lot of energies. And we can use this wind energy, we can use windmills to convert that into electrical energy. Then what is a strain energy or elastic strain energy? The energy is stored in the object due to deformation or change in length, shape or size. So example, if you have a rubber band and you apply force on this rubber band and you stretch this rubber band. So when you stretch this rubber band, whenever object deform, object changes shape, size or length, it will store energy. And which form of energy it store? We call it store elastic strain energy. So whenever objects store energy due to deformation, change in length, shape or size, it will have elastic strain energy. Like example, a catapult. So if you place a stone here or a pebble and you pull this catapult backward, so when you pull it backward, the rubber will stretch. When these rubber will stretch, which form of energy these rubbers will have? So they will have elastic strain energy. And when you release this catapult, the stone will come out, the stone will start to move. So when stone or a pebble is moving, which form of energy it will have? It will have kinetic energy. So basically, the elastic strain energy changes into kinetic energy of the stone. Same way, an archer, when he pulls the string or a wire, so when he pulls this string or a wire backward, so which form of energy this wire will have? It will have elastic strain energy. And when he release the arrow, the elastic strain energy changes into kinetic energy of the arrow. Even if we have a spring, we compress the spring or we stretch the spring, it will also store energy, and that energy is known as elastic strain energy. Is it clear, the concept of elastic strain energy? The energy stored in the object due to deformation due to change in length, shape, or size. So these are the forms of energies. Now that is law of conservation of energy. What is the law of conservation of energy state? Basically, we are not creating energy, we are not destroying energy, but we are changing the energy from one form to another. So energy cannot be created, cannot be destroyed, but it can change. It only changes a form from one to another. So everyday example of conversion of energy from one form to another, like example, a stone throwing upward. So if I'm holding, example, I'm holding the stone in my hand. So which form of energy I have? I will have chemical energy. As I throw this stone upward, the stone start to move, kinetic. It is at certain height, it will have potential, but at the maximum height, it will have potential. When it is coming down, it will have kinetic and some potential as well. But when it hits the ground, it will produce heat and sound. So basically what happened, the energy transformed from one form to another. Example, if I have 100 joules of chemical energy, when I use that 100 joule, so what will be the kinetic energy here? 100. What will be the potential energy? 100. When again kinetic? 100. And when it will release heat and sound, the total sum of heat and sound will be equal to 100. So energy is actually not created, not destroyed. It actually changes from one form to another. How heat is there? Because of air friction, when two objects come in contact with each other, the friction is there between the surface, and the friction between the surface can produce heat. Heat or internal energy is there. A small amount of heat energy is there, neglected, but it is always there. So first there is a chemical energy, then transformed into kinetic as we move, then transformed into potential, then again transformed into kinetic, and then it produced heat and sound. Is it clear? This example of conversion of energy, the energy change from one form to another. Yes, Abdullah Khan, Heather, Shazib. So example, a waterfall. So if a waterfall is there, as we already discussed, it will have potential here. When it is coming down, it will have potential and kinetic both. But when it is hitting the surface, start to move, it will have kinetic and it will also produce sound. So it's gravitational to kinetic, as well as sound will be there. Energy calculation, how we can calculate the energy? If you want to calculate the kinetic energy, what is the formula to calculate the kinetic energy? Anything which is moving will have kinetic energy. So the formula of kinetic energy is half mv square. So you have to learn this formula, that kinetic energy is half mv square, where m is the mass, v is the speed. So a word example, a car of mass 2000 kg traveling at a speed of 10 meter per second. Calculate the kinetic energy. So how to calculate the kinetic energy? The kinetic energy is half. Even you can learn, half means 0.5, so I can write directly 0.5 mv square. Half means 0.5. So 0.5 multiplied by mass, which is 2000, and speed square, so it will be 10 square. So we will multiply all these values, we will get the value for kinetic energy, which is 100,000 joules. Is it clear, the word example and the formula of kinetic energy? So you have to learn this formula of kinetic energy, which is half mv square. But I advise you, instead of writing half mv square, better write 0.5 mv square. Because some student got confused with this half, that they sometimes they multiply this 2 with mass and velocity. So that leads to a wrong answer. It's better write 0.5 mv square. Then how we can calculate the gravitational potential energy, the energy? Yeah, the scientific calculators are allowed in exam. How to calculate the gravitational potential energy? The gravitational potential energy is energy which is stored due to change in height, and it can be calculated by a formula multiplying mass with gravity with height. So mgh, potential energy is mgh to calculate. So example, a stone of mass 5 kilogram is lifted to a height of 2 meter. The gravitational field strength or value of the gravity is 10 Newton per kilogram. So we need potential energy. To get the potential energy is mgh. So mass is 5, gravity is 10, and the height is 2. So 5 multiplied by 10, 50, 50 multiplied by 2, that's equal to 100 joules. The unit of energy is joule, so you will write capital J. Newton meter can also be used. There is also a unit, Newton meter, but you can write joule. Now I want everyone to participate. You can use the screen annotation to state the answer. The ball is at rest at the top of the hill. So the top of the hill, there is a ball which is at rest, not moving. It rolls down, so it is coming down. At the bottom of the hill, the ball hits the wall. So there is a wall example. The ball hits the wall and stops. Which energy change occur? Internal energy means heat energy. What is the energy change? A, B, C, or D? And I want everyone to participate. You can use either screen annotation or a chat to state the answer. Yeah, what about others? Heather, Basra, Shahzeb. So it will have potential energy first, then it changes to kinetic, and when it hits, it will turn into internal energy. That's good. In this question, we have to calculate the increase in kinetic energy. How much kinetic energy increase? So in the question, the mass of the car is 1500 and it was moving with a speed of 20 meter per second. Then it accelerates until the speed is 25 meter per second. So what is the increase in the kinetic energy or change in the kinetic energy? So there are two kinetic energies. First, we'll find kinetic energy for 20 meter per second. The formula for kinetic energy is half mv square. So it will be 0.5 multiplied by mass, which is 1500 multiplied by 20 square. So what is the answer? Can you state the answer for this? 20 square multiplied by 1500 multiplied by 0.5. What's the answer for this? 300,000 joules. So this is 300,000 joules. Then there is a new kinetic energy, because if the speed changes, the kinetic energy will also change. So new kinetic energy is 25. So it will be 0.5 multiplied by 1500 multiplied by 25 square. So what is the new kinetic energy? 25 square multiplied by 1500 multiplied by 0.5, which is 468,750. Okay, 468,750 joules. Now, what is the increase in the kinetic energy or the change in the kinetic energy or difference in kinetic energy? So what is the difference in the two numbers? You subtract them because we want to find increase. Yeah, the difference. So the difference is 168750. That's right. 168750 joules. But if you see, all the answers are written in kilojoule. Yeah, 168750 joules, but all the answers are in kilojoule. So we have to convert into kilojoule. So joule to kilojoule, we divide by 1000. So if I divide this by 1000, what will be the answer? It will be 168 kilojoule. And 168 kilojoule, what is the nearest to 168? So that is C. So C will be the right answer. Is it clear discussion? Because they're asking the increase in the kinetic energy or the change in kinetic energy or the difference in the kinetic energy. The diagram shows a part of a roller coaster ride with the car at different positions. As you can see, the car runs freely down from position X to position Y and up on the other side. What happened to kinetic energy and potential energy as the car moved from X to Y? So as it moved from X to Y, the potential decreases, as well the kinetic will increase. That's good. So C will be the right answer. Okay, in this question, a train of mass 2.5 kilogram is stopped by compressing a spring in the buffer. So these springs are there. So this train is stopped by compressing the spring. After the train stop, the energy stored in the spring is 0.48. So if energy stored in the spring is 0.48, what was the energy of the train? The energy of the train was also 0.48 because the energy of the train is transferred to the spring. So if energy stored in the spring is 0.48, what was the energy of the moving train? That was also 0.48. We have to calculate the speed of the train. So how to calculate the speed of the train? As the train was moving. So basically what happened, yeah, we assume in practically it is not true that all of the energy transferred. Practically some of the energy transferred in other forms, like maybe sound. So basically what happened in this question, the train is moving. So as the train is moving, it is having kinetic. But when train hits this buffer spring, the train will stop and the spring will compress. So spring will have elastic energy. It will also produce sound energy, but we assume, this is our assumption, that if the train was having 0.48 kinetic, all of its kinetic energy is transferred into spring. This is our assumption, but practically it is not possible. There are other forms of energies as well, but we assume that only one form of energy is transferred. So we need the speed of this train. As the train was moving, which form of energy train will have? When the train was moving, which form of energy it will have? Kinetic. So we can say kinetic energy will be equal to half mv square. So instead of writing half, it's better write 0.5. What is the kinetic energy? That is 0.48. 0.5 multiplied by mass. What is the mass of the train? It's only 2.5 kilogram. That's a toy basically. So 2.5 multiplied by v square. So this is 0.48 0.5 multiplied by 2.5. That's equal to 1.25. So this is 1.25 multiplied by v square. Now 0.5 into 2.5 is 1.25. Now we need v here. So 1.25 is multiplied, other side it will divide. So it will be 0.48 divided by 1.25 is equals to v square. So when 0.48 divided by 1.25, that's equal to 0.384. So 0.384 is v square. But what we need, we don't need v, we need v square, we need v. So if we need v, what we do to remove this square, we'll take a root both side. So we'll take a square root both side. No, not divide by 2. When square is there, we take a square root, under root. So square will cancel with root. On what is the under root of 0.384? On your calculator, you can find this under root 0.384. So when we want to remove the square, we take a root, under root. So under root of 0.384, that will come out as 0.62 meter per second. Is it clear? So 0.63 meter per second. Is it clear, this question? How we use the kinetic energy to get the speed. Another question. Different cars have has a mass of 1500. It collide with the same wall, and all of its energy transferred and absorbed by the crumple zone of the car, like the front side of and the back side, they tend to deform, and we call them as a crumple zones. The energy absorbed by the crumple zone is 4.3 into 10 to the power 5. Show that the speed of the car is 24. So it's a similar question. Basically, when the car is moving, it will have kinetic energy. But when the car hits the wall, all of its kinetic energy transferred into the wall as elastic energy. So if the wall absorbed 4.3 into 10 to the power 5 joule, how much kinetic energy of the car was there? That is same 4.3 into 10 to the power 5 joule. So we'll use the same formula, that kinetic energy of the car is 0.5 mv square. Kinetic energy is 4.3. So 4.3 exponent 5 means like 4.5 multiplied by 100,000, which is 450,000. So this is 430,000, not 450. That is 0.5 multiplied by mass is 1500 multiplied by v square. So 1500 multiplied by 0.5, that's equal to 750. So it will be 430,000 and 750 into v square. 750 is multiplied, other side it will divide. So 430,000 divided by 750. What is the answer when you divide 430,000 divided by 750 equal to 573. So basically 573.3 is equals to v square, but we don't need v square, we need v. So what we do at the last, we'll take under root. So what is under root of 573? It is approximately 23.9, which is 24. So 23.9 meter per second. Is it clear, the first part? And suggest what would happen to the car if it is traveling faster than 24. So if, for example, this car was moving at 24 meter per second, if there's another car which is moving at 30 meter per second, so what could happen to the car? 23.9 is approximately equal to 24. So you will write 23.9. So what happens if the car approaches this wall at a higher speed? It will have more damage. So today we discuss about the energy, the definition of energy, energy transformations, the different forms of energies and energy transformations. Any question related to the class today?